Okie dokie. So revision exercise 5. Revision exercise 5. So again, here it's split into 2 exercises, but like I said, it's easier than the one we just did. So this should be quick. Yeah, I was also just doing what I was doing in the break. Yes, it's just one row. So 5.1, it says a potato chip manufacturer wishes to determine if 5 different flavors of chip that the company produces are equally popular. Equally popular. Maybe let me do this. Let me highlight that rather. Equally popular. Okay. A random sample of 1,000 customers were asked to indicate their favorite flavor from those made by the company. The results are given in the following table. Okay, so there we have our results. Okay, and then it says perform the appropriate hypothesis test at 1% significance level to determine whether the chip flavor is equally popular. All right, so immediately we go again. We said step number 1, assumptions. Isn't? So we have H0 and H1 as usual, and H1. So what are we going to have as H1?
H1.
Mm-hmm.
H0 is not true.
What?
H0 is not true.
Well, for H1, yes. H0 is not true. It's the opposite. And there you get your mark. I'm sure there's a mark there. But then H0, what is the assumption there? Satisfied. Well, here we're not looking at satisfaction, is it? Yes, the context of this particular situation.
It's equally popular.
That's it. Remember, in H0, we want the equal sign.
Yeah.
So we're saying that the flavors are equally popular. Okay, so you can even say flavors equally popular, or you can say the population, in other words, the number of people who choose flavor A, because remember we got 1, 2, 3, 4, 5, okay, is equal to the population that chooses flavor B, is equals to the population that chooses flavor C, population that chooses flavor D, population that chooses flavor E, okay? Or, yeah, you can say popularity is flavor, I'd say flavor, and then go equal popularity across the flavors. That's another way that you can pitch it, okay? But at the end of the day, we are saying we've got the same popularity across the different flavors. So here we are. We've got our assumptions. We now move to step 2, decision rule. And then we are saying here, we want to get your, yes, we want to start with the DF. In order to find out your critique, we need to start there. But this time for DF, we have to change the formula. We can't use the previous one because the previous one was focused on what? What were we testing there? There we were testing for independence. Is there a relationship? Is there not a relationship? And we were testing for homogeneity. Where is it the same in terms of satisfaction? Remember? So here we're saying, is it the same in terms of popularity? Okay. So we're basically saying with these different populations, with these different flavors, do they get the same population? All right, people who choose the flavor. So here you're going to use the formula K minus M minus 1, where K is the categories, and we have 5 categories because we got 5 flavors. And then here they said M refers to the parameters, okay? But we don't have any parameters, so this is 0, okay? And then minus 1. Okay, remember we always want to reduce the row by 1 or reduce the column by 1. Okay.
don't you use that bracket method?
Which
Low
bracket?
minus 1, first bracket, total brackets.
Yeah,
Bottom minus 1.
because that degree of freedom calculation pertains to homogeneity and independence. Here we're then looking at popularity or population. You see.
And then, so what shows us that there's no parameters in this?
So in this one, you can see when looking at the different categories, you don't have parameters. All you have is number of customers. Yeah. What I think I should do is, because I Googled that, I chat GPT'd that. So to find out what does M stand for, because I saw the formula and I was like also curious that what does M stand for. But here you see. So here they say M represents the number of parameters or predictors in the model, excluding the intercept term. Okay, so M is the number of estimated, therefore number of independent variables or features in the model. So it still is not clear. It doesn't give an example. Let's see. So here, example. If you have a model with 3 parameters, say 2 predictors and an intercept, okay, and are comparing it to 10 observations. So all we have is observations or categories. Can you see that? We have 5 flavors. Those are our categories. All right. So K, see, so K is definitely your observations or categories. And then M, since we have 2 predictors, we don't have any predictors. All right. And then -1, it's always going to be -1. So there we go. But yeah, I think it would be good to chat GPT more illustrations of like practical examples, so you can actually get a full breakdown and actually relate it to a question rather than just, okay, parameters or predictors. I think predictors makes more sense to me. There, if we're looking at predictors, I would be looking at your linear programming, but now with more than just one independent variable. Because remember, the independent variable is the one that predicts the dependent. Yeah. So that's the closest thing that comes to mind. Right. So this is obviously then 4. So we've got our degrees of freedom. Our alpha or our level of significance is 1%, which is the same as 0.01. So now we can get our critique or crit.
13,270.
Eesh, what the hell just happened? Let's undo that. So
13.277.
Okay. So again, we know. We are going to reject. Okay, maybe let me do this first. Remove this table. And we are saying, okay, if our chi stat is greater than this 13.277, what are we going to do? Reject the null hypothesis. Okay, so we now have our decision rule. We now know what we're going to do once we have our so step number, maybe let me do it over here. No, you know what? Yeah, it's fine. Let me do it here. Step number 3 is to then calculate your expected value and your chi stat. All right, so this is what I was busy with this whole time, just to save us some time here, because I think we're now really getting the point of this. So we've got our table there. We want to get our expected values. But in this question, what did they say? They said a random sample of 1,000 customers were asked to indicate their favorite flavor from those made by the company. Okay, so this is what I actually wanted. Determine if the 5 different flavors of chip that the company produces are equally popular. So if 1,000 people were involved in this sample, right, and they're saying this thing is equally popular, then what is our expected number of people that select flavor A, flavor B, flavor C? 1,000 is the total number of people that were involved in the sample. So the total expected value should equal 1,000. But then how much people pick flavor A? 190. That, yes, from our observation, that's what happened. But how much do we, when it comes to expectation, isn't we're saying we expect that these flavors are equally popular? So shouldn't then the same number of people that pick flavor A should be the same number of people that pick flavor B, C, D, and E? So that means to get that value, which should be equal across all of the flavors, we simply say 1,000 divided by what? Divided by 5, because we got five flavors, which gives us 200. Okay? So here it's 200 in each of those slots. So this is why, guys, I'm telling you, things like stats, accounting, if you've never practiced, it's shy. Because you need to be seeing this question before. Otherwise, you get stuck here saying, how do I get the expected? You see? All right. So there we are. We've gotten that. Now, after getting that, we then say, oh, we now need to calculate our x stat. But we can't just do that because remember the formula is we need the summation of what? The observed minus your expected squared divided by your expected. Okay, we want the sum of that. So here I've just already calculated the expected, and we can again at random, let's just calculate C for instance. So we can say 200 minus, sorry, it should be 220 here. 220, isn't the observed there for C is 220. Hey, what's going on here? Minus 200, yes, divided by 200. No, we're getting, yes, we're calculating the observed here, not calculating the expected, because the expected, yes, we would divide by 1,000. Okay, in a different scenario though. Yeah. So what do we get here? You're basically going to get 20 and then square it. 20 squared, that should give you 400. Divided by 200 should give you 2. Okay, so we are getting number there. Which next one should we randomly calculate just to make sure? E, okay, right. So they were saying 185 minus 200 this time. So that's obviously going to give us a negative 15, isn't it? Negative 15 squared divided by 200. What do we get? 1,125. Okay, so our values there are correct. We're happy with that. So then you just need to add these values to get the sum. Isn't we want the summation, isn't it? You get the total. So if you add those values, what do you get? You said 3,25. Oh, why, guys? Why are you saying minus? It's positive.
I'm saying,
There's something you missed. because this is already 0.5, 0.5, so that's 1 plus, that makes it 3. So,
Plus another one. So it's four.
yes. So that should be 4 and how much? 4.25. That's what you should be getting. You can just double check there.
So not 4.50 or something.
Should be 4.
125, 125.
Yeah. So you're happy, yeah? Because 125, so it's the same as saying 12.5 plus 12.5 gives you 25.
Yeah.
So it should be 4.25. We happy? Okay. So then, now that we have that, we can now move to step number 4. All right. And step number 4, okay, I'm just going to stick with this color so we have something to distinguish. We know is comparing. 2 and 3. What we've calculated in 2 and 3. Okay. So here we can see what? This is our 2 and this is our 3 over here. So you can see that 4.25 is less than 13.277. So what are we going to do?
So it's not a reject.
Yeah.
Accept.
We can accept. We can accept what? Yep. Accept the null hypothesis, HO. Okay. So number 5, we are simply saying we do not reject. We do not reject HO at that let me do it. I said 1%, huh? Yeah, significance. And therefore, can conclude that the different flavors are equally what? Popular. Double L, popular. Isn't. And we're home and dry for 5.1. Okay. So that is 5.1. Do you want to take a picture before I erase, or? Okay, at least this is now all in the same space. Okay, right. So now let's see. Okay, let me just erase. That would be the easiest way to go about this. Yeah, let's do this. We can just erase that. That's fine. This is going to change. So it's probably going to change as well. Okay, that formula will stay the same, but this is probably going to change. And this is going to change. Okay, right. So with question 5.2, let's see what's going on there. Here they're saying, a hairdresser salon manager claims 30% of clients visit the salon on Saturday, 20 on Sunday, 10 on Monday, 10 on Wednesday, 15 on Thursday, and 15 on Friday. The salon is closed on Tuesday. The table below indicates the number of clients who visit the salon per day over a randomly selected week. Okay. Perform an appropriate hypothesis test at the 5% significance level to determine whether the salon manager claim is true. Okay. So here again, you can see H1 is going to have your equal sign. So you're going to say Sunday is equals to 30%. Or is it Saturday? Saturday. Let me do Sat. Is equals to 30%. You want to say something? It's fine. Okay. And then here, Sunday is equals to 20%. Monday is equals to 10. Okay. And then what? Wednesday, 15%. 15%. And then what? Friday, 15. Then what? Oh, that's done. Okay. So then obviously the alternative is that is not true. So then the decision rule, how many categories do we have? We have 6. And again, we don't have any predictor, so that's going to be 0 and -1. Okay, so this will give us 5. And we said this is at what confidence level? 5%, isn't it? Same as 0.05. Okay, so now we can begin to find out our chai critique. Okay, and I'll just give it to you because I think now at this point we know what we are doing. You're getting 16.75. Oh, guys, I just said you know what we're doing. Where are you getting 16 points?
So that's what it says. 0.05%.
Yes. And then what is your degrees of freedom? Gentlemen. What's going on here? No, you guys are looking at 0.005. Can you see?
Wait, so 0.005 is what? It's not 5%.
Yeah, that's half.
Half of it. Oh. Yeah, makes sense.
Look at the
Uh-huh. Okay.
Yeah, 11.07.
Okay. So now we know our decision rule. We're basically rejecting if we get it 7-1.
Yeah.
Okay. Yeah, I see in your textbook they went with 7-0. I'm not sure why, but yeah,
So
you're right.
Question, like, do they say, since it says 5% is the level of significance, do they say half a percentage? Then we have to determine that it's 0.005.
No, it's not supposed to be 0.005.
So like I'm saying, what if it
Oh,
is?
if they yes,
What do
yes,
they say?
they can say that. They
But
can
then-
say.
So they don't give us a number.
They can also do this because they can give you the number 0.05.
Percent.
Or let me do this, sorry, because that's wrong actually.
How would that be written in the Pacific?
It would be like this. This is 0.5%.
Okay.
Can you see?
Yeah.
Yeah. Okay.
Makes sense.
And maybe let me just finish it.
0 minus 5. So,
No, that's good.
oh, that is
0.0.
Okay.
Yeah, makes sense.
Makes sense? Okay. Right. So step number 4 again is to compare, but we have to. So let me get rid of this table here. And I want to bring this table that I had down here. Zoom out maybe. Yeah. So again, they gave us this information in terms of number of the clients or customers that came in, right? And they've told us that these are the percentage of customers that are coming in, right? And they told us that if you look at the question, they've given us the total customers that come in for the week, which is 800. So off of these percentages, we can work out how many should be coming, what our expected value should be. Okay, so here, 800. Okay, and then 10% of 800, you'll get, this thing is now causing me problems. You'll get 80. Is it 10% on Monday? Yes, 10% is on Monday. On Wednesday, 15%. So that should be 120. Then Thursday is also 120. Then Friday is also 120 because it's also 15%. Saturday we say is 30, so that's 240. And then Sunday is 20, so that should be 160, yeah?
Yes.
Am I right?
Yes.
Okay. So now that we have our expected values, we can obviously get now this, at least for each of the days, right? So again, you're just saying, let's do it for, we are saying 65, yes, minus 80 squared divided by 80. And then I'll just do one more. We have, let's say Thursday. Let's just do Thursday. Minus 120 squared divided by 120. Okay, what do we get? What do we get?
First one is 2,812.
Okay.
Second one is 0,83.
That's it.
3. 3. Yeah, 3.
Okay. Cool. So here I'm just, it's exactly what we get here on the answer. So here 2.8125. Now you see your answers are not consistent just in terms of 1 minute they're working to 2 decimal place, the next minute is 4. So yeah, very interesting.
So if the question doesn't tell us, we always work to 2 decimal places.
Yeah, just for your final answer.
Yeah.
So here, remember, these are not our final answers because we are adding them all.
Yeah.
So it's fine. Yeah. And then 0.6250. So then the total you should get here is 7.40. Okay. And we are even already home and dry because now we know all that we need to then do is compare. So we've got 7.40 and we know that's less than 11.071. So again, we're concluding we do not reject the null hypothesis at, this time is 5%, isn't it? So we just need to change that to 5%. And we therefore can conclude that what was the whole, that the management claim is correct.
Yeah.
That the management claim is correct. Can you see how I've just dodged the whole bullet of having to explain or speak to each and every one of those days that the management claim is correct? Because remember, the manager was claiming these are the percentages of customers on each of the given days. Right. Gents, that is your school fees for today. I don't know if you have any questions. Okay, but if you want to take a picture, you can take one before we call it. Maybe let me just zoom in here a bit. Again, you see the challenges. Degrees of freedom, you don't have the formula. And yeah, is there anything else?
Decision.
The decision rule.
Yeah, no formulas.
Yeah,
Yeah,
yeah. So yeah, guys, I said at the beginning, I know they give you a formula, but I strongly suggest you create your own formula